So today we're gonna go through a lot more examples just so we can really get our hands around lists. Before I start today, so I asked you to do the matrix transpose over the weekend, yeah? Did anyone do the matrix transpose over the weekend? Nice hustle, guys. Yeah, good on you, right? 2. That's okay, we'll do it again today. But before I mention that, I want to tell you a little bit about shallow copies. There is a nuance about lists that I didn't tell you because I didn't know this was a nuance about lists. So this is something that we've all learned, well, will learn. If I make a list like this, so it's a list of lists, right? So X's is the list comprised of the list 101 and the list 21, yeah? Oh. How come it took you so long to let me know? A+ to whoever mentioned it first. There we go. Okay, shallow copying. So suppose I have this list X's, and X's is comprised of 3 lists. The list 101, the list 210, and the list 321, right? So we learned this little nuance that if I were to just say X's is equal to Y's, what we in fact have is 2 names just pointing to the same list. So changes to X's would change Y's, and changes to Y's would change X's. So what I recommended that you do in those cases is copy the list. So you properly have 2 separate copies of a list which you can modify. So if I would append 4, 5, 6 to X's, what would happen in this case to X's? What does append do? It adds it to the end of the list. So it's going to add the list 4, 5, 6 to the end of the list. Okay? If I ask for what happened to Y's, it should be the case that Y's was left alone because I made a copy. Y's was left alone. Okay. That's not the nuance. This is the nuance. Okay? If I take the first element of Y and extend it by 2, 3, 4, right? I'm just going to add 3 more things. The first element of Y gets extended, right? That list. It's right here. Okay? If I now look at X's, it's changed its first element. This is why it's a shallow copy. We've done a copy at the highest level, but the lists inside the list aren't copied. Right? Those remain as pointers. Right? So study this slide a little bit. Right? You'd have to copy the outer list and then copy the inner lists to get a true copy of the lists. Right? So I don't know if this would ever come up, but maybe one day you'll have a weird bug and this will explain it. Right? So we're shallow copying a list. That means we're only going to get a copy of the outer bracket. So just be mindful of that. Okay. So today maybe we can actually define matrix multiplication as I wanted to do the other day. So I'm just going to define Monday here. Okay, so let's just go through this. So I'm going to import something from typing, just my normal list. And I want to do something like define matrix transpose. And this matrix transpose, so I usually denote my matrices by like this double A. This makes sense because in math, we usually denote matrices using the blackboard bold like this. Right? So I just use double A or double B, right, just to denote the blackboard. Okay, so this is going to be a list of integers, let's say. Let's only work with integer matrices for the time being. And this is going to return a list of integers. Okay. Returns the matrix A with rows and columns swapped. And let's give this at least a couple examples. So if I give this the matrix with 2 rows, let's say, and the first row is 1, 2, and the next row is 3, 4, the matrix transpose return should be, so the rows and columns are inverted. So the first row is the first column, which is 1, 3, and the second row is the second column, which is 2, 4. The matrix transpose for empty should be what? What is the empty matrix with its rows and columns exchanged? Perfect. Let's do one more. Just the constant. So matrix transpose of 1 should be 1. Wait. That's wrong. Why is this wrong? What is the smallest matrix? Nope. 1 by 1. How many rows and columns in a 1 by 1 matrix? Yeah, there's 1 row and 1 column in a 1 by 1 matrix. So I believe I have to do this. Right? So remember that my matrix, the way I'm choosing to represent matrices here are by list of rows. Right? And the 1 by 1 matrix, in fact, has 1 row and 1 column comprised of 1 element. Right? So that would have been a mistake by me. This is the smallest, well, this is the technical smallest matrix, but this is the technical smallest non-trivial matrix. Okay, so this is going to be our strategy here, right? Swap rows with columns, right? So what I want to do is I want to build an answer. What is my return type? List of list. What should I start accumulating from? Empty list. Okay, and I'm going to return that answer eventually. Okay, so this is why this is a good problem, because I need to think of what I got to do. I have to construct, so what I want to do is I want to have some type of loop here. I don't know what it's going to do yet. But I basically want to say, I want to do 2 things. I want to construct an answer, and I want to construct a row of the answer, right? So first I want to construct the 1 row of the transpose. And what will 1 row of the transpose be? Well, I have to walk down the first column of A, and then the second column of A, and then the third column, and so on. Okay, but I can only access the columns. I can only access rows of the input, right? So I have an A row, right, in AA. That's the first, so I can pull out a row, right? So what's the first thing I need to do after I pull out a row? Maybe I have to draw a matrix. Sorry, YouTube. Okay, this is row 0, row 1, row 2, row 3. This is row 0, row 1, and row 2. I can pull out individual rows, right? So if I loop through this, right, this is AA, and its first element is the row 1, 2, 3. I want to pull out a row and then look at its, say I want to pull out the first column. I want to pull out the first row and then take its first element. And then pull out the second row and then take out its first element. Then pull out the third row and then look at its first element. Okay, so I'm going to do this. So how many columns are in this? How can I get the number of columns? Okay, easier question. How can I get the number of rows?
The length of the list at index 0.
That's the list. That's the number of columns.
Oh.
Yeah. Okay.
Wait, what?
You have to follow this or you're not going to be able to do your second assignment. The second assignment is all matrices, right? So let's try to get our energy up. I know it's Monday, but this is ultimately going to help. Right? This is a list of lists, yeah? Okay, how many lists are in the list? So how many rows do I have? How many columns do I have? Okay, okay, hold on, let me add one more column just so we can have it different. 10, 11, 12. Okay, let's repeat the experiment. How many lists in A? How many rows in A? Okay, how many columns in A? What has length 3?
The list inside. The list inside the list.
Okay? If the matrix has at least one row, right, then I just have to ask for the length of that row. And the length of the row is the number of columns. bunch of nods. At least there we go. At least half of you. The other half of you can go home. It's Monday. I don't care. Okay. So the number of columns is what? What should I type? I want the length of something. What do I want the length of? Zero. Yeah. So this may crash the program, actually. Right? Because if we have the empty case, then this will crash. So what I'm going to do is I'm going to say, I want to say this. If the input is empty, return empty, right? Just so I can assume that the matrix itself has at least one row. This is not very Pythonic, although it's more clear. The Pythonic way of checking for empty is this way. Right? Remember, anything that's empty will evaluate to false. Anything. A list, a string, right? So anything that's not empty will evaluate to true. So if not AA is actually testing if AA is empty or not, right? This tests if A is empty. I actually prefer the right-hand side, but the left-hand side is what they want us to do. It's more robust, right? Because there's many different ways you can be empty. Okay, so now that I'm here, this means I can do this number of columns without the program crashing, right? Because I'm not asking for an index that doesn't exist, right? When you're using list indexing, you have to be careful to make sure what you're indexing actually exists. When we're using loops and saying for something in something, we're fine. If it doesn't exist in it, it won't loop, right? So it's always more safe to use the in keyword rather than doing direct indexing. Anyways, so I have the number of columns. Okay, so for every row in A, I want to construct a row of the answer. So a row, all right, so I'm going to construct a row of the answer for every column. Okay, so how do I get the columns? For column number in range number of columns. Okay, so what this is going to do, it's going to pull out, this is wrong. I have to reverse these. This was a tricky piece of code, right? That's why I gave you all weekend, right? Okay, so I want to build the columns one by one, right? So I'm going to say column 1. Now how do I get column 1? Well, so to construct a row of the answer, I want to append the row that I've just pulled out at the column number. Okay, so outer loop. Outer loop is going to count from 0 to the number of columns. So suppose I run my outer loop once. It's going to set the column number to 0. And then it's going to go through every row of A and look at the 0th element and collect that into a row. So what has that done? I've collected into a row what used to be a column. Right? And then I'm going to move the column number to 1, look at all the rows again, but this time look at the first element of the column. And then move columns to 2, look at all the rows and pull out the second column. Okay, maybe I can do some printing while, so we can see how this works. So I've made a row. After I've made a row, I need to append that row to the answer. Not extend, append, right? Because we're appending rows, right? Row of answer. And then in the end, I want to return answer. So, hope and a prayer. Let's see if this will work. Python input Monday. Oh, I'm not on my desktop. Python input Monday. Oh, colon. Okay. Matrix transpose empty. Great. Matrix transpose on the simplest thing. Great. Okay. Yeah. But yeah, that worked. Let's try this. Did that work? Yeah, because the original thing was 2 rows by 3 columns, and the new thing is 3 rows by 2 columns. Right? I can't really print it out nicely. When we start talking about objects, like the better way of doing this would have been to make a matrix object. And then I can tell Python how to print these things. And anyways, that's an advanced topic. Okay, so I have the matrix transpose. Yes? That wasn't too... Very simple code, but you have to think about it a bit. Right, so this is what I want to try For your second assignment, think first and then program. Right? Programming is the very, very, very last step. Right? You first have to treat these assignments like math problems. Right? How would I solve this? Right? Write your code on. So your exam's in 2 weeks. You're going to be asked to write code on your exam. So practice writing code. When you do your lab this week, I want you to write the code onto paper and then type what you wrote on the paper into the computer. Right? Just to see how closely you can compile. Because we can, if we feel like it, depending how the marks are going, mark you down for missing semicolons and stuff when writing. Right? No syntax highlighter or compiler when you're doing it on a computer. So I implore you, well actually, if you want to prepare for the midterm well, start preparing coding on paper. Okay. Is everyone comfortable with this matrix transpose? Or do you want me to like throw some prints in here and we can see what it's doing? All right, okay, so yeah. It will crash and burn, yeah. But like the answer to this is not, let's write like a whole suite of error checking. It's like, I wrote this here. Again, this is called the contract for a reason. The contract I'm entering in with the user is, if you give me a matrix represented as a list of lists, then I'm going to return to you a matrix represented as a list of lists. Actually, there's extra stuff that we need here, right? Like the number of rows. The rows can't vary in length. Like I can't have a row of length 3 and then a row of length 1. So there'd be a bunch of stuff that we have to check. But it's normally the case for us that we're assuming all the input is correct. Because there's going to be some other program doing the type checking for us. We'll get one of the high school students to code that up, right? Let them do that, right? Okay, so now that matrix transpose is finished, I want to write the matrix product code. Oh, why did I return answer twice? Because I liked it that much. Okay, so let's do matrix product. All right, so that has to take in 2 matrices, list of ints. B is a list of int. And this is going to return a list of integers. And this is going to, who cares? This is going to return the matrix product. Okay, so the matrix product of, boy, I should have prepared these ahead of time. Okay, so if I have 2 1-by-1 matrices, this should be easy. That's just going to return 3. But let's try doing something more complicated now. Okay, so maybe I should do this on the board first, then code after. Okay. Does everyone remember matrix multiplication? I'm going to cover it anyways. Okay. Okay, so remember first that matrices have dimensions. It's the number of rows by the number of columns, right? So a 2-by-3 matrix has 2 rows and 3 columns. This is 2-by-3. And a matrix which is 3-by-4, say, will have 3 rows and 4 columns, right? And the fact that these are equivalent is important because the resulting matrix is going to be 2-by-4. Any of this ringing a bell from high school? Okay, right? For YouTube, I've written a 2-by-3 and 3-by-4 matrix on the board. The elements are just the numbers 1 through 18. I'm now going to write the resulting 2-by-4 matrix on the board. I'm not going to fill them all in, though. Okay, so the resulting matrix should be 2 rows by 4 columns. And a position here gets filled in with a dot product, which we've written already. So you just find the column. Right, so this is in this column and this row, right? So it ends up being the dot product of this column and this row, right? Familiar? Okay. I'll write the general form. The ijth position of the matrix product is equal to the ith row of A times the jth column of B. Right? Or this is the ith row of A times the jth row of B transpose. Right? When I transpose something, I'm exchanging its rows and columns. So the jth column of B is the same thing as the jth row of B transpose. Right? This is why I made you guys write B transpose. Because I want to now go through all of the rows and do this dot product. Right? So it just occurs to me that I don't have the dot product, but let's just do it right now. Dot product. I'm going to take a list of x's of ints and a list of y's of ints. I'm going to return a scalar. Okay. Mathematical dot product. Let's do something different here just for kicks. So we have this thing called add. Do we? No, we have this thing called sum. Yes, we have this thing called sum. So I'm going to use some list comprehension here. Return the sum of x's at I times y's at I for I in range the length of x's. That's more of a close definition to the actual definition of dot product. Don't worry. I just wanted to show you a cooler way of doing the dot product. So I'll just write maybe advanced solution, for which I mean you don't need to know it, right, until maybe next year, right? So don't stress. I just wanted to show you some list comprehension. Maybe we should test that. Dot product 1, 2, 3, 4, 5, 6 should be 32. I hope. Okay, matrix product. So I'm going to have an answer here that I want to construct, and I again want to construct rows of the answer, just because we've decided amongst ourselves that matrices are going to be stored by a list of rows. So I'm going to return this answer by the end. Okay. So what do I want to do now? I want to go row by row and do a dot product. Okay, so if I pull out, so how can I build a row? I'm just asking this because I'm trying to figure it out. So I pull one of these rows out, and then I build a new row by dot producting with every column. Yeah? So this is what I do. For an A row in AA, let me do this. So I'm going to say BBT is equal to the matrix transpose of B. So for a row in A, and for now a row, well, this is actually a B column, right? Is everyone okay if I write that? A column of B is a row of B transpose, right? B transpose is just B with rows and columns exchanged, right? So, were you guys really strong with math in high school, it would seem? All top students? You guys are going to have to become very well acquainted with matrix algebra, basically. Computer science and linear algebra are best friends, besties, right? The whole discipline of numerical analysis is how to use matrices in a computer, right? Because you guys know a little bit about float intolerance. So just imagine the float intolerance when you're doing matrix multiplication. So at least do put some effort into trying to remember your linear algebra because you're going to need it like crazy. Anyways, I'm pulling out a row in A. I'm pulling out a row, a column of B. I want to make a row of my answer. So what should I append to my row of my answer? Well, that should be the dot product of this row and this column, right? So I pulled out a row, and I'm going to look at all the columns into a dot product, and that should create a row of the solution. And then I just want to append this solution row and return. Okay, if you don't quite, huh? What happened? What's wrong? It's a new fancy way of spelling append. I'm so good at computer programming, Python would have known what I was talking about. Right? It would change all the keywords for me. Okay, let's hope and pray that this works. No errors. That's a good first sign. Let's try just the basic. This should return 2. Please work. What did I do? A row and B call. Everyone gets to watch me debug. Isn't this fun? Line 46. Row answer is the dot product. Oh, I have to append. What am I doing? Append this. Yeah. Let's try again. 2. Okay. 1, 2, 3, 4. This should return a 2 by 2 matrix. Wait. This is 1 by 2. No, I need to do a 2 by 1. 2 by 1. Oh, no, that is right. 1 by 2 and 2 by 1 gives 1 by 1. Okay, so a 2 by 1, this is 2 by 1, and 1 by 2, that should return 2 by 2. 2 by 2. Okay. I'm pretty confident this is working. Right? You can go home and test it. If you don't understand it now, well, that's probably like 90% of you, right? You're going to have to go home maybe and study this a bit, especially if you don't remember how to do matrix multiplication. You never learned matrices in high school. Who else didn't learn matrices in high school? Oh, tell me these things! I could have gone and shown you this. Did I not ask? Okay, that one's on me, guys. That one's on me, right? I just assumed, well, I did high school in Ontario like 10 years ago. I didn't assume that much stuff has changed, but geez, you guys have it easy. Well, Okay, stop. We got to continue going. You guys should learn this anyways, because you're going to need it, right? You shouldn't have skipped linear algebra in high school. That's on you, right? It's not going to show up on your test next week, but do know how to work with matrices, right? Especially this notion that the way that you've been given them only really enables you to walk a matrix row by row, right? It's much more difficult to access matrices in this fashion. But in any case, let's move on. We can go. Oh, geez, 10 more minutes? That took a long time. Okay, you guys are going to have to know how to work with nested lists on your midterm. So I'm going to try to do some nested list examples. Remember last week I gave you a really nice program where we checked to see that every student enrolled on a team was also enrolled in the school. And I was like, this is really beautiful. Let's strive to do a little bit more of that today. So let's assume that students are uniquely identified by integers. And then let's write a function that checks, students must be broken into teams so that no person is on 2 teams. Assuming students are uniquely identified by integers, let's write a function that checks that no person is on 2 teams. Does that make sense? Okay. So I'm going to take just a list of teams and return a Boolean. Okay? It's Monday. Okay, I'm just going to put this up top here. What did I call it? Valid teams. Valid teams. So I'm just going to take a list of teams. Teams, which is going to be a list of lists of integers. And this is a Boolean function. Maybe I should call this isValidTeams then, just to stay with our conventions. Checks that no member is on 2 teams. Let's see how I can do this. Right, so for a team in Teams, what do I need to do? Right, so I can pick a person out of this team. What do I have to ensure? This could easily be a midterm question. Okay. I am concerned, right? Yeah. Okay, good. That's a good start. So first of all, I'm not asking you guys to spit back code at me, right? I'm trying to help you guys understand how you get from like a question to like actually writing code. So like the first thing, this was absolutely correct. What you said. I'm sorry. It was said that we need to ensure that this person is only in one of the teams, right? Of the member of teams, right? So for person in teams, I need to count how many teams this person is in. So I'm going to do it, maybe I'll do it in a simple way. So out here I'm going to say number of teams is 0, okay? Then I'm going to say for person in team, I want to go, okay, again, I need another team variable. So for team, because I have to loop through teams twice. This team in teams, right? It's perfectly fine to write Python code like this, right? It's no less dirtier than saying team 0, team 1, team 2, which in my opinion would be equally confusing, right? So for team in teams, for the number of teams is equal to 0, for person in team, for this team in teams, if person is in this team, right, then the number of teams this person is on is incremented by 1, right? So, and then after that person's done, if the number of teams that this person is on is greater than 1, then return false immediately, right? And if this whole thing executes without returning false, then we can return true. So why don't you let that sink in. This probably isn't the most effective way of doing this either, right? I could probably do this with list comprehension as well. Oh, I could do this really cool with list comprehension. Okay, so this is a solution that we'd expect you to be able to produce. I'm going to give you the more Pythonic list comprehensive solution. Do you want to see that one as well? Okay, I'm not going to delete this in case you want to study it, so I'll just put it underneath there. So for a person in team, I can create this list. Watch this. I'm going to get rid of this number of teams. How many teams is this person on? Well, this person is on, I'm going to do a list comprehension. I'm going to test person in this team for this team in teams. Okay? So I pulled out a person. I'm now going to do this list comprehension. Person in this team is a Boolean. It's going to evaluate to false or true. Or it's going to evaluate to 0 and 1. There's going to be a 0 in this list every time the person's not on the team, and a 1 in this list every time a person is on the team. Given that there's a 1 in this list every time that a person is on this team, if I take the sum of this list, right? If the person is on more than one team, the sum is going to be at least 2, right, of this list. So now it's the same thing. I just eliminated one of the inner loops using a list comprehension. This is more Pythonic in a way, right? This is much more direct, actually. So that will work as well. How much time do I got? 10 minutes? Okay, let's do this one. This one's kind of cool. So you guys know what the Cartesian product is? Oh, that wasn't a question. That was a statement. I'm saying you guys know what the Cartesian product is, right? Because you've seen it again and again and again and again and again in school. They just haven't called it the Cartesian product. What do you guys call the plane? R2. What do you think the 2 meant, right? R3 is 3 space, right? So you've been using this notation for a while now. They haven't told you what it was called. So when you take a set and you put it to an exponent, this is called the Cartesian product, right? So you give me 2 sets, and I can form the Cartesian product in this way. So if you give me 2 sets, A and B, the Cartesian product of A and B is all of the pairs such that the first thing in the pair is from A and the second thing in the pair is from B. If A is of length 4 and B is of length 3, how many elements are in the Cartesian product? Oh, that example's very wrong. There should be 9 things in the solution there. I don't know why I only put 3. Okay. The answer is 9. Okay, so this example's wrong. So I'm just going to show you the example because now this is unfair. Okay. Definition, Cartesian Cartesian product. I'm going to take two lists, a list here and a list here. And I'm going to return a list of lists. Well, a list of tuples, actually, but I'm going to make them lists. Returns the mathematical Cartesian product. And I'm going to give you a couple correct examples. Cartesian product of, let's see, A, I hate using strings so much. B, C, and let's do 1, 2, 3. So the Cartesian product here should be, okay, I'm going to kick off one of these letters because it'll be too big. There's going to be 6 pairings here. And the 6 pairings should be 1, 2, 3, 4, 5, 6. Should be A1, A2, A3, and then B1, B2, B3. Okay. And then the Cartesian product of anything with the empty set is empty. Okay, so I want to accumulate an answer here and then return it. So you see how I write code? I just sort of fill in as I go, not necessarily top to bottom. And I'm just putting in all the pieces that I feel I'm going to need eventually. And you can always rearrange them. That's the magic of using a computer. So what do I need to do here? I need to take an element from A. Okay, I should call this A's and B's. Oh, I can't use A's. X's and Y's. Okay. 4 X's and X's, 4 Y and Y's. And I need some type of answer. Append to this answer XY. And that's going to do it. Ta-da! That one was quite easy, actually. Okay, so there's a bunch more questions I didn't get around to today. I want you to do them for practice. I'm gonna put these on the labs. Okay, so write a function that constructs a list by zigzagging through the lists. So to zigzag, you go 1, 3, 2, 4. Right? I don't know why this is called flatten. It should be zigzag. To zigzag this, it should be 1, 4, 2, 5, 3. To flatten this should be 1, 3, 2, 4, 5. So you zigzag for as long as you can, and then when one of the list runs out of elements, you just append whatever's left from the other list. So try this one. This is a good midterm difficulty question. This one's fun. Suppose you represent a number like 234 by the list 234. Write me a procedure which adds 2 integers that are in this form. And don't forget about carrying, right? This is hard. So for an advanced question, write me a function which takes a list of lists with an arbitrary amount of embedding and removes all of the brackets so that you're only left with one straight list. We're going to be doing file input output next class. Start studying now. Come see me on Wednesday, and I hope to God I don't see any of you in my office for the law of hammer, right?